Good evening, everyone. Welcome to this Matlab Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. And today's topic is RCNN using Matlab. Okay, give me a minute. Let me check this one. Okay, today's topic is RCNN using Matlab. First, I would like to welcome the early comers. Thank you for your time and thanks for coming. And Tamiru, good evening. Pratik, good evening. Getachev, good evening. Meenakshi, good evening. APL Investments, good evening. Balaji, good evening. Dr. SP Rajashekar, good evening. Mohammed, good evening. Disha, good evening. Ravi Kumar, Abhishek, Dania, Kundik, Kailveli, Sumit, Dinesh, Tarushi, Mullat, Sandra, Dinesh, Bevkat, Najia, Sweta, good evening. Rafik, Ishwari, and Mitiku, Sishir, good evening. Felix, good evening. Harshita, good evening. Sneha, good evening. Lavanya, good evening. Kadidja, good evening. I received your email, Kadidja, like I'll go through it. Abhishek, good evening. Harsh, good evening. Lilo, good evening. Kishori, good evening. Siddhumani, good evening. Control Learner, good evening. Ahmad, good evening. Chandranath, Ravi Kumar, Jalal, Chandranath, Farhan, and Soundarya, Krishna, Jagadish, Kiran Kumar. So, good evening to all. Thank you for your time. Thanks for coming. And today's topic is regional convolution neural network using Matlab. So far in deep learning, like we have covered up the basic CNN, okay, how to develop the convolution neural networks from scratch, and then we have gone through the AlexNet, the transfer learning concepts. We have gone through the transfer learning concepts, and yesterday, like we have covered up how to do a simple face recognition algorithm using the transfer learning concept. And today's topic is about regional convolution neural networks. It's quite different from the convolution neural networks. It has both the classification as well as regression. Okay, so today's topic we'll be learning how to detect face using RCNN, face detection using RCNN. The same code you could also use for object detection. Okay, object detection and classification. The same code it will work. The same process, no need to change anything. It will work for object detection. Okay, so let's go for the topic. And before we go into the topic, I'll give a short introduction about Pantec and about me, and then we can go for the session. Okay, about Pantec. So Pantec was started in the year 2004. Like we basically manufacture microcontroller boards, DSP boards, and FPGA boards. We do also manufacture a lot of trainer kits for electronics as well as for electrical engineering. So our vision is to help 10 million students to learn the technology in an easy way. Give me a minute. Okay, sorry, I forgot to enable my face. So our vision is to help 10 million students to learn the technology in an easy way. So far we have covered up around 1 lakh plus students on YouTube, and this year we have a mark of around to cover up 8 lakh plus students on YouTube. So we have a lot of upcoming webinars, as well as we have masterclass series out there. So please stay connected on our channel if you want to learn more. So the upcoming sessions are like we have IoT 30 days masterclass series on IoT and self-driving car. Okay, 1 week program on self-driving car, that is also there. So you could, if you want, that is free on YouTube. If you want, you could attend and you could enrich your knowledge. Okay, so about me, my name is MK Jeevarajan. Like I have provided my LinkedIn link here. Like if you want to connect, you just send me a connection request. I'm happy to connect and happy to help. Okay, so I have around 18 plus years of experience on the board design as well as on image processing and video processing, and like I'm responsible for the research and development team in Pantec. So I'm happy to share my knowledge with you. So if you want to connect, just send me a connection request. Okay, so coming to the announcement, the attendance link will be available at 9 p.m. So minimum attendance required for an e-certificate. Okay, minimum required for an e-certificate is 27 days. We may waive off 1 or 2 days. So 25 days. Even if you have 25 days of attendance, you are eligible for an e-certificate. And those who have attended all the 7 series of 7 days series on deep learning will get a separate certificate, like deep learning workshop certificate for 7 days, workshop certificate on deep learning. Okay, so for some sessions, if I'm not able to present it on live, I'll be using the recorded video streaming. Like so far, like we have crossed around 17 days, and it may be 1 or 2 days. Okay, I'll try to present it on live for all the 30 days. If I'm not able to make it on live, I will be playing a recorded session for 1 or 2 days. Okay, videos will be removed from YouTube for after 3 to 5 days of time. So you have to practice within that. And if you want more than that, then you have to pay for the access for 6 months, for the access of 6 months, where you could download the PPT as well as the source codes. Okay. And today mindset lesson is about like for every setback. Okay, whenever you have a setback or whenever you fail, there's a gift. You have to uncover it. So remember always, whenever you fail, remember always there is a gift on it, and the thing is you have to uncover the gift. Okay, so this is the lesson which I'd like to share you today. So let's go for the RCNN program. Okay, so if you're ready to learn, just type RTL in the chat box. Just type RTL in the chat box. Deepak Shah, good evening. Atulsan, good evening. Narendra, good evening. Bashit, good evening. Amruta, good evening. Shishir, can we please go back at 8 p.m. because it's getting late every day. It's a request. Shishir, like actually there's a program on machine learning, like which where Sanjay is taking around more than 1 hour, like 1 hour 15 minutes of time. So 8:15, the program ends at 8:15. Okay, so I will try, but the 8:30 to 9:30, we have only 10 more days to go, like 13 more days to go. So after this series will get over. Maybe of the next series, like we could open it around at 6 o'clock. Okay, 6 p.m. In the evening. Bashid Khan, good evening. Vasantan Raja, good evening. Janvi, good evening. Begum, good evening. Banu Krishna, good evening. Satyaram, good evening. Afra, Pravat, Hemant, Raja Gupta. Yes, Raja Gupta, I'm sorry today is late. Like I was trying to configuring my cameras and like the system. I'm sorry, like tomorrow I will be on time. Thank you so much, Karan Kumar, Chatura, Ahmad, Wontan, and Abhishek Gupta, Flow of Thought. Okay, Dr. S.P. Rajshekhar and Sundari Tribhuvan. So thank you so much. Let's start with the categories of algorithm. So this slide, which we have caught up earlier, like on the basics of learning, like we have supervised as well as unsupervised learning. Okay, in this we have two categories of algorithm: classification as well as regression. So far we have caught up only classification, right? Classification, and we have not caught up the regression. But this RCNN, it includes both classification as well as regression. Okay, so it includes both classification as well as regression. So like classification, you could use support vector machines or naive Bayes or KNN algorithm, whereas for regressions you could use n-sample methods, regression trees, and linear regression. Okay, regression is prediction, whereas classification is just classifying the class. Okay, just classifying the class. So what is classification was what is prediction. Okay, so if you give this image and you predict that as a car, then it is classification. If you map a bounding box on this image, then if you map the region of interest, then it is called then it is prediction. Okay, so in prediction what happens is you estimate the width and height of the bounding box. You estimate the location, like there are four coordinates on the bounding box. You have the xy location as well as the width and the height of the bounding box. Okay, so you predict the width and height of the bounding box. Whereas classification, you give an image, you just classify whether it is car or like car. It classifies the object. Okay, it classifies whatever the class you train. So classification was prediction. Is that clear? Is that clear? Abhishek Kutta. Okay, is that clear? Classification was prediction. Okay, so classification, like you have the cat. This is classification plus localization. Okay, class object detection. Okay, and this is instance segmentation. This is bounding box, and this is instance segmentation. Segmentation, like you will be grouping of the pixels. Okay, exact objects. So this for instance segmentation you will be using semantic segmentation. Okay, we will be using semantic segmentation. Okay. So what is RCNN? What is RCNN? RCNN is a regional based convolution neural network. Okay, where it has both the classification as well as the localization. Okay, you have both the classification as well as localization. So you get the bounding box of the object as well as the class. You could also have multiple class. Okay, multi-class is also possible. And like where you give the input image to the network, RCNN network, RCNN regional convolution networks, where you have the region of interest layers. Okay, it extracts the regional proposals and then it applies to the CNN algorithm. okay, where it finally like this regional proposals will be they will be using clustering algorithm, like they use selective search algorithm or k-means algorithm to group the data, okay. And then like after warped region will be this warped region will be applied to a convolution neural network, where it further classify whether it is a person or an aeroplane or whatever the class it is, okay. So this regional proposals, like if you give an image to the system, you give an image to the network, it extracts the regional proposals, it extracts the features here, and then it applies the classifiers, okay. It applies the classifiers and it finally classifies the class. This is classification. On regression part, you get the width and height of the bounding box, okay. Here the image is the regional proposals has been like the regional proposals like has been grouped and it applied to the classifier. Here you will be having multiple proposals, okay. In that you have to estimate the width and height, which is the best estimation, which is the best bounding box. So that regression is done by the regression algorithm, that prediction is done by the regression algorithm, okay. So you have both classification as well as regression. So regression estimates the width and height of the bounding box, whereas classification will tell you that regional proposal is person or flag or ball, okay, or the background. So regression will give you the bounding box, width and height. You estimate the width and height and xy location also. So bounding box, you will be having 4 coordinates, okay. Width and height, you will have the width and height and the starting location of the bounding box, xy value. So all these values will be predicted by using regressions, okay, regression algorithm. So for extracting this regional proposals, it uses a hierarchical clustering model, okay. You could use a hierarchical clustering at different scales, like this, like you have multiple box, okay, and you apply the CNN algorithm and it chooses the best box based on the score, okay. So for this, for example, if you have a person, like you could see a multiple box here, you could see a multiple boxes here, only one boxes will be predicted, only one box will be predicted, so which has the maximum score. This clustering, this box, this regional proposals like is estimated by using a clustering kind of algorithm. Clustering is nothing but it's grouping of similar pixel values, okay, grouping of similar pixel values, grouping of similar data, okay. So you have the input, you estimate the regional proposals, you extract the features, apply for a CNN classifier, apply for the regression. So classifier CNN will give you the class and the regression will give you the bounding box. This is how RCNN works, okay. So coming to the applications, like it could be used for the autonomous driving, okay, smart surveillance system, or the facial recognition system. So today application is about face detection or object detection. So we are going to see both offline as well as real-time face detection, as well as the offline object detection. The same code without any modification, you could also use it for object detection, okay. So in RCNN, like you have 3 categories. One is RCNN, fast RCNN, and faster RCNN is there, okay. So RCNN, like you have the like for regression, like they use support vector machines, okay, to get the bounding box refinement layer. So in fast RCNN, like they have the regional proposal functions. Here they have in fast RCNN you have the pooling layer to maximize the speed, okay. To RCNN, like it has only the regional proposal functions to get the features, features. When fast RCNN, you will be having the ROI pooling layer to reduce the number of bounding box to make it fast, okay. And faster RCNN will have a regional proposal network, okay. It has the function, it has the network, regional proposal network, as well as the ROI pooling layer. So that's fast RCNN. So let's go for the code, okay. There are only 5 steps here. There are only step 2, step 1, step 2, step 3, and step 4 and step 5, okay. There are only 5 steps. The first step is to prepare the ground truth, okay. The first step is to prepare the ground truth. Here, like we'll be using an image labeler command. First I will explain you the command on the presentation, and then we can go for the MATLAB. Okay, so first you have to use the image labeler to get the ground truth. Okay, to get the ground truth. Once you prepare the ground truth, that's step one is to prepare the ground truth. Okay, step two is to load the RCNN layers, and this data layers is available on MATLAB. Okay, it's a pretend network. So you load the data layers. Okay, and set the training options, and step 4 is to train the RCNN director. Okay, we have used train fast RCNN director, train the director, and step 5 is to test the network. Let's go for MATLAB. Okay, so I have a database here. So I have a database, like I have the face image here. Okay, I have the face images. Okay, so I just copy this path and change the path. Change the path. Okay, you go for apps, click image labeler app. Okay, you search for image labeler. There are, like, you could also use image labeler as well as ground truth labeler. Image labeler, you have to install the computer vision toolbox. Only then, like, you will get this image labeler command. So click image labeler. Okay, so it's taking some time. Okay, so once you got, okay, once you get, click new session, load, add images from folder, choose add images from folder, you choose the database, click open. Okay, just click open. I choose all this image, click open. Okay, so if you have a video, then use video labeler. So in this session we'll be using image labeler. Okay, so you have option to create label, ROI labels and scene labels. Okay, the scene label is applicable, for example, when you use a video, or when you use a when you want to do a self-driving car. Okay, where you could have multiple scenes on the camera, so that you could describe the scene here. Okay, the ROI label will give you, like, ROI, like, you have options like label, you have an option to choose rectangle labels or line label or pixel label. Okay, first I'll show you the rectangle label. You give any name, like I just give this as the name as face and click OK. Okay, I just crop. Okay, this is one type. Right click, I just delete this one. Okay, I click, and you could also have a pixel label. Okay, you could also have a pixel label. When you use a semantic segmentation kind of thing, like, you could use the pixel label and you could map this as face. Okay, map this as face. Okay, so you could also, like, you could also like map eyes. Okay, eyes. Okay, so you could have multiple labels. So this is pixel label. Okay, this is pixel label. So we are going to use in semantic segmentation, we'll be using the pixel label. On today's session, like, we will be using only the rectangle label. Okay, I have not used the line label. Let me check. Let me check what is the line label. Give me a minute. Okay. 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 So you could okay, I have not used the line label. This is the first time I am trying out. So I have used only the rectangular as well as the this rectangle as well as the pixel label. Okay, so I just go for the rectangle label. I choose face here, click OK. Okay, so just drag and drop. Okay, just drag and drop. Choose the next image, drag and drop. Okay, choose the next image, drag and drop. So you have to do it for all images. For example, you have 10,000 images, you have to do this for 10,000 images. So that's going to take more time, because for cropping one image, if it takes like 5 seconds of time or 10 seconds of time, like you just multiply it into 10,000. Okay, so it may take like more than like 30 hours of time or 40 hours of time. It depends upon the number of data sets and number of classes you have. If you have multiple class, then it's obviously it's going to take it's going to take 2 or 3 minutes per image, so that will cost you more time. Okay, so mostly company outsource this thing to Amazon MTech websites. There's a lot of freelancer websites are available, like where they will do it for just 50 paise or 1 rupee for cropping this image, and they will provide the tool for ground truth. So they used to crop the data and they will provide, like you could give 10,000 images and 20,000 images to the freelancer websites, like where they will done the job within 5 days of time or 10 days of time. Okay, so you have to crop all this. You have to crop the face. Okay, I have cropped the face here. Once the process is done, you just go for export. You have two options. One is export labels to workspace and export as a ground truth as a table format. Okay, if you are using YOLO algorithm, you go with the ground truth. If for RCNN, like it accepts the table format. Click OK. So I'm going to export the labels to workspace. So it is going to store in workspace. So if you check here, it should export. The G truth has been created here. Okay, the G truth has been created here. So you could save this G truth, save of G truth, because when you use clear, this will go off. So you save this G truth. Okay, so this G truth.mat will be here. So even if I clear, and I could load this one, load G truth. Okay, is that clear till this point? If you want me to repeat, just type repeat. Okay, explain how RCNN is working. Najia as well as Shai Harsa Reddy. Okay, see, I will. Okay, so you give an input image. Okay, you give an input image. So what happens is, the first thing is to get the regional proposals by hierarchical clustering algorithm. Okay, so clustering, it groups the data. It groups the similar pixel value. It groups the similar pixel values, and it forms as a cluster. Okay, it forms as a cluster. This pixels, this data, this grouping, this clustering, once it clusters the data, it extracts the features, like you get the regional proposals. The output will be the regional proposals. There will be lot of regional proposals will be there. Okay, not see, if you could see this box, like for this person, like you will be having more than 10 or 20 boxes. Okay, with nearest boxes, you have to choose the best one. So once you extract the regional proposals, it is then sent to a feature extraction. Like it extracts the features, like where it has the network. okay, where it has a CNN, convolution neural networks, which has a convolution which extracts the features from the regional proposals, not from the image, from the regional proposals. So this regional proposal, you will get a class, okay, you will get a class, you will get the class for the regional proposals, okay. It is also passed to a regression unit where it estimates the best bounding box for the regional proposals, okay. So the bounding box is nothing but you will get the starting xy location of xy location, and then you have, like, you got the xy location and width and height of the bounding box. You will get the width and height of the bounding box, okay. So you get both the classification as well as the, so RCNN will give you both the class as well as the bounding box coordinates. So Bonu Prakash is okay. Why 2 times G truth? Okay, I will explain the image labeler one more time. See, I just close this image labeler. Okay, I just close, save the session. No, you could also save the session. I'll tell you how to save the session. You could open image labeler by typing image labeler on the command window, or you could go for, you just go for apps, and you could also search for image labeler here. Okay, image labeler. There are 2 ways you could load the image labeler here. See, you have video labeler, video labeler is also there, and image labeler is also there. You just click image labeler. Okay, image labeler. So it opens the image labeler here. Okay, so start a new session, load, add images from folder or from data store. Data store is nothing but if you have image data store, then it loads the images from the data store. Else you go for, this is to load the previous session. If you have a previous session, you could also load the previous session. I'll show you how to load the previous session. You add the images from the folder, like I choose all the images and click open. Okay, so here you have 2 kinds of labels. Scene labels is also there, and RY labels. If you have different background scenes, okay, then you could also have a scene label. Okay, so if that will also that will also give you a classification on the background. So we are going to use RY labels. And RY labels, there are 3 types, but I have used only 2, like the rectangular and the pixel label. Okay, the rectangular label, you just click, you give a name for the label, click OK, and you could choose this one. Okay, whereas the pixel label, whereas the pixel label, give me a minute, I will post attendance, give me a minute. Give me 1 moment, please. I'll post attendance. Today is day 17, right? Okay, I'll pin this attendance to the top. Okay, I just pin this message to the top. So the attendance link is in the top. The full form of RCNN is Regional Convolution Neural Network. Okay. Okay, let's go for so you just crop this one face, you just crop the face here, choose the second image, crop this face, third, okay, just crop the face. Okay, Okay, I just crop the space, go for export labels to workspace, choose as table. Okay, export format as table, export format as table, click OK. It overwrites the data which was stored here. So now you could save this one. You could save this one. So save of gtruth. Okay. If you want to save the session, like save session. Okay. You click save session as image labeling session.mat and save the session. So if you want to save, if you want to load the session, like if you want to modify the session, then you could load the image labeler. You could open the image labeler and you could load the session. You load the session. Okay, just load the session. Okay, just load the session. Is that clear? Is image labeler is clear? Just type clear in the chat box. Is that clear? RCNN stands for regional convolution neural networks, region based convolution neural networks. Is that clear? Just type clear in the chat box. I'm waiting for your chat. APL Investments, thank you. Is that clear? Oh gosh. Classification is a class. Is that clear? I'm waiting for a chat. Is that clear? Just type clear in the chat box. Lavanya, thank you. Tulsi, thank you. APL Investments, thank you. Shoshana, thank you. So we have only 4 to 5. Shabana, Shishir, thank you. Kadidja, thank you. Darshi, thank you. Pascal, thank you. SP Vijayanand and Dr. SP Rashekar, sir, thank you. Nimesh, thank you. Sudarshan, Vanshika, controller, thank you. Rajesh Das, thank you. Surya Prakash, thank you. Felix, thank you. Sumit, thank you. Aravindan, thank you. Okay, let's go for you just type edit in the chat box. Okay, so edit in the command window. Okay, so CLC clear. Okay, so this is to close all the programs, close all the figures which has opened the previous program. I just load the gtruth. Because we are using clear, so I just load the gtruth. I also load this data layers.mat file. This file will be available on Matlab. Load data layers. Okay, so I just put a stop command to keep a breakpoint. Okay, example 1. Okay, so I just put a breakpoint here. Okay, just to check the layers. So data. So these are the fast RCNN layers. Okay, I just copy this fast RCNN layers. Okay, layers equal to data.fast RCNN layers. Okay, so train data equals this gtruth. Train data equals this gtruth. Okay, help training options. Help training options. You have to configure the check temporary folder here as it will create a mat file here. So I copy the training options from this. Okay, PPT. Okay, help you just type help train fast RCNN object director. Okay, help train fast RCNN object director. help vision. Okay, help vision. So we have to take the command for the fast RCNN object editor. Let me check for the vision toolbox. I forgot the command. Give me a moment. Just type help vision on the command window. So this will give you the list of commands on the object editor. Okay, you just go for faster train first RCNN object editor. Okay, just copy this command. Put help train fast RCNN object editor. Okay. So I copy this one. Okay. It should be 0.2, 128. So here we have to pass the train data. Train data here. Fast RCNN layers, like the layers. Okay. Options, training options. You have to pass the training options. Okay. So let me check. Save this program. Okay, save this fast RCNN. Save for CNN. Okay. I run the program. So it gets the data from this ground truth. Okay, it loads the data layers, get the fast RCNN layer. Okay, it was just extracting these layers here. So the training has started now. Okay, so it's taking some time. So we have around 5 epochs. Let's check. So first it has completed only one epoch. So if you don't have plot, like you cannot stop this program at mid of the training, like only you have to break. There's no way to stop the training process at the mid of the program. Data layer is the RCNN layer. The data layer. Okay, it has the RCNN layers here. Just the name actually. Okay, so we got 83% accuracy. Okay, now to test this one, CLC, like I use help UI get file option. Help UI get file. Okay, UI get file. Copy this code to choose the image. Okay, to choose the image, and file name equals okay. Okay. So we have to apply that for a predict. Okay. You just type help detect here, help okay. I just copy this one. I load this FR. I load this FRCNN. Okay. Save this program as example 3. Okay. And this is the image. Okay. This is the image. So FRCNN like label. Okay. Bounding box. Let's check. Let's check for the output on the program. I choose this one. Okay. I choose this image. The first image. Okay. So we got a lot of box. Give me a minute. We need to have only one. Run the program again. So okay. So we need to optimize this dimensions. Let me check for the smaller dimensions. Okay. So I retrain the algorithm again. DBQ niche. What is use? See, are you asking about this one? Or are you asking about this one? Niche. DBQ is for just for quit the debug mode, like for this DBQ. Okay, to come out of the debug mode. Okay, so this is in debug mode. Okay, but we cannot use dbq at during the training process. You will not get the command window itself. Okay, so let me check now. Still we got some error. Okay, we go by default 0.2. Okay, 128 number of regions to sample. We should get only one phase, like it is extracting multiple region proposals. Give me a minute, like me check now. Is it possible to result convert into, yes, you could convert, if you want to convert that to Excel file. Sharma, like you could do that. Cropping can be done on different sessions. Yes, like you could load the session, you could load the session back, and you could also crop it back again. Okay, let me check now. It should work, else we have to change the code back again. Okay, not bad. So okay, still we have few misclassifications of that. Okay, still we have few misclassifications of that. There is no detection for this one, for this phase. Okay, and this is perfect. Okay, this is perfect. So one phase has been detected properly. So let us try for a real time one. Real time, like I'm going to use the same code yesterday. Open like okay, I'm going to use the same code for storing the image. Okay, for storing the image. Let us check for the real time, like example 4. Okay, so I run the program. So I got the preview. Okay, okay. Actually, we don't want this phase detection now. Right click, I comment this one. Phase detection. I just get the snapshot. We don't want crop also. Okay, I just get the snapshot and I store only the image here. I just only store the image. Okay, let me check. Okay. So I delete this one. I delete this image. We recreate this one image. So bounding box. Okay, bounding box. Okay, it's not bound. It's not going inside this bounding box. Okay. Let us check now. Okay. So it is creating the image. Okay, it is creating the image. So we have 21. I'm just going to take 30 images. I just keep a breakpoint. just copy this images. I just copy this 30 images to folder called data. Okay. I just open image labeler app. I just load, click new session and create load add images from folder. Okay. I have choose data and I choose this file. Okay, there is a bug on the MathWorks image labeler tool. It won't allow one.jpg. Okay, I forgot this. Like this one.jpg will not be allowed inside. Okay, so I just delete this one, two. I delete. Okay, let me check now. Load add images from folder. It needs minimum two. Like, let me check again. No, no. Give me a moment. I'll close this window. Okay. I just include str cat here. I just include a frame. Okay. Frame. Let me check now. So it won't allow this one.jpg, like it won't allow, like there's a bug on this only in 2020 A and B versions. 21 the bug has been shot out. Okay. I open image labeler app. Okay. Let me check here. Okay. Let us check. We got frame 30. We got frame 30. So I stop the program. Debug. Okay. I just copy this. I just copy frame 1 to frame 30. Frame 1 to frame 30. Okay. To data. I just go for the image labeler tool. Now if I import, like click new sessions, load add images from folder. Okay. Data, I choose this folder, image, click open. So now like you could see the images is loading now. Okay, previously it was not. So the reason is we start from one.jpg. Okay, so face, I click face, click OK. I crop this face. Okay. So I have to do it for all the 30. If you could save the session and later you could open the same session and you could also crop. Okay. So for example, you have 1000 images and you have completed only 100 images. You could save this as a session. Okay. And the remaining images you could load the session back and you could do it again. Okay. You should not leave anything empty, like the training part, it will show error. Okay. I have saved this one image. I give this as new. Okay, I have saved the session, export to workspace, and this is table format. Okay, click OK. Before that, I will cross verify once. So I'm checking the, like, is that any images missing or not? Okay, perfect. Okay, I close this one. So save of gtruth. Okay, now I load this. Now I run the program of example 2. I run the program again. So I'll go through your chat, like why it is a niche, like the image 1.jpg is not ordered because actually it's a bug on the image labeler tool. Okay, it minimums require 3 characters before the jpg. Before the jpg, like one has only one character, right? 1.jpg. At least it should work at 11.jpg. I'm not sure like why it was not work, but if you give 1.jpg, it won't work. It should have a name like at least like fr1, fr2, fr2, fr1.jpg, fr2.jpg, at least 3 characters. Okay, so that's a bug on image labeler tool. Is that clear? Just type clear in the chat box. So far, is that clear? So far, is that clear? I'm waiting for your chat. Yes, Ponusami, like I'm going to use the real time now. So different images. I'm not. I'm going to use real time. Like real time, I'm going to get from the camera and I'm going to check it for the face detection. Dhanam API, the wrong detection is due to these settings, like the parameter. You have to configure the parameters correctly. So the overlap range, the negative overlap and the positive overlap range, and the smallest image dimensions, these things you have to configure it correctly. Lavanya, thank you. Nish, thank you. So we only 3 more epochs. Bob Suri Prakash, thank you. So meantime, like we can complete the code for the real-time process. Like I just copy this same code. Okay. I load the director from here, like load so load FRCNN. Okay, load FRCNN. Instead of classify, we are going to use detect here. Okay, I just comment this line. I click and comment. Okay, and I'm going to insert this shape. Okay, so this is not required, so I just remove this line. Face data is not required. Okay, so example 5. Okay, so let's check for the command window. Let's check for the command window, like whether the training is completed. Like Mohammed, thank you. Sai Sudar, thank you. Solomon, thank you. Kadija, thank you. Ponnusami, thank you. Sumit, thank you. Kabiru, Dhanam AP, thank you. Sundari, thank you. Okay, Dr. Espira Sher, thank you. So we have one more epoch to go. Like we have 91.41% accuracy. So once the training process is done, the same code you could use it for object detection. Okay, you could get the camera for Apple detection or something like that. Apple orange. Okay, you crop the bounding box. Okay, just crop, and then you train the network. Then show it in the camera, like it will detect the bounding box for the Apple. So we have only one epoch to go. Okay, so it's complete. It's saving the program. Okay, it's saved now. Okay, now I try to run this one, FRCNN, load FRCNN. It should work. Let me check. So this is the preview. Like, I'll just take this one. Okay, so but there are some misclassification is still there, but some frames is okay. Some frames is okay, but still it's there. Okay, we could improve this one by setting up the parameters. See, now it's okay. Like, for some frames it's okay. Okay, for some frames it's okay. Okay, so we could improve by configuring the parameters. Okay, by configuring the parameters. We could just close this program. I'll explain. I'll give a small recap, and I will close the session. Okay. So here, like this, only this part, this parameters we have to configure correctly. Else, like, you'll get multiple bounding box, and like, you load the first, you get this gtruth from the image labeler command. Okay, first get this labeler from the image labeler command, and you have to load the data layers, RCNN layers, fast RCNN layers. Okay, and this you could load the ground truth. Train data, you just load the ground truth and set the training options. Set the training options and set train fast RCNN object where we give train data layers and the options. Okay, and save FRCNN. So so it will take the remaining parameters by default. Okay, but you have to configure this correctly so that you will get the correct output. And here, this is for getting an input image. To load and as a webcam, I get the image. I configure the webcam. I get the snapshot from the cam, and I just store the image. I'm not using this because this is a yesterday program. I'm not using. Sorry, example 4 actually. Okay, so I commented this line. So I just save the frame. That's all. I just save the frame. I'm using this face crop. This phase editor, anything I have not used. I just save the input frame, the snapshot. See, I am getting this frame here, and I just write this frame here. That's all. I'm creating a file name and just store the file. In example 5, we load the FRCNN webcam preview, get the snapshot, and detect the RCNN. Okay, so detect, there we use classify, here we use detect. Okay, and it gives you the bounding box, the score, and the label. Okay, so insert shape and related image. So with this, I close the session. Thank you so much for your time. Like, I will take the questions. Before that, let me switch on this. Okay, so we have the batch to internship registration, like it's going on, like okay. So you could avail this internship registration, like where you have 30 days of video coaching lessons, and we can live Q&A sessions. So this Saturday we have the live Q&A sessions. So internship certificates, as well as you could download the project source code. You could download the project source code, and you could download the PPTs as a PPT format. Okay. You also have the bonus session on next week on bonus sessions on the resume building and LinkedIn master, as well as personal branding. Okay, and you have access to the private group, Telegram group. So all this is available at 750 rupees, and the combo course is also available, the Matlab masterclass plus embedded system design and Arduino. Okay, so you could download the presentations and like download the projects, and you could use it for your resume. Okay, so all this available at 999 rupees. So you could avail this offer. With this, I close the session. Thank you so much for your time. Thanks for coming. And, I'll take down the questions now. Priyadarshini, thank you. Kosa, thank you. Nish, thank you. Flow for, thank you. Aravindan, thank you. Kadija, thank you. Is the direction valid for any object you want to? Yes, yes. But I recommend you to use YOLO. Okay, this RCNN is almost, it's like absolute, like you could use YOLO, which works better than this. Okay, you have a lot of reference codes on the Mathworks site of YOLO v1, v2, v3. Okay, if you want to use better object detection, Kadidja. Okay, Vikash, thank you. Fatima, thank you. Sudarshan, thank you. Smith, thank you. Chandranath, thank you. Banu Prakash, thank you. Shabana, thank you. Atvisan, thank you. Jodi, thank you. Mohammed, thank you. Sai Sudip, thank you. So thank you so much for your time. Thanks for coming. See you in the next session tomorrow. Until then, bye bye. Thank you. Take care.